In this video, we're going to go through writing a logarithmic expression in an expanded form. We have two examples that we're going to do here. So here we have the log base 2 of z to the third divided by xy to the fifth power. So here we've got a division problem, so we're going to be able to turn this into subtraction using the quotient property. So because we have one thing on the top and we have one thing on the bottom, so the top and the bottom, we'll need two log base 2's. From there, we're going to take the top thing and put it first. And we'll take the bottom thing and put it second. And we'll have subtraction because it is a division problem. Now from here, because we have this xy to the fifth power, notice that inside of here we have a multiplication. So we have something else that's going to be happening. So right here we've got multiplication happening. So this is going to turn into two more logs. So we have our original log base 2 of z to the third, and now we're going to subtract this whole next, and this whole next piece is log base 2, and we're going to need two of them, and the reason we need two of them is because there's two things inside. So we're going to have a log base 2 and a log base 2, and the log base 2 is of a x and then a y to the fifth, and because those are being multiplied, we then get to say that we are adding those two things. Now from here, we can do a couple different things. We need to distribute our negative sign, and we also need to take the exponents and move them to the fronts. So I'm going to end up having 3 times the log base 2 of z minus the log base 2 of x minus 5 times the log base 2 of y. And now I have everything down and simplified out and expanded. And so that's going to be my final answer. Let's take a look at our next problem. Here we have the log of the cubed root of x plus y quantity squared divided by 10. So we're going to want to write this radical expression with rational exponents instead. So we're going to rewrite this. This is going to become the log of x plus y quantity squared over 10 all raised to the 1/3 power. Now from here, we want to take our exponent and move it to the front. So we're going to have 1/3 times the log of x plus y quantity squared over 10. Now from here, we want to deal with our division, right? So we have a top and we have a bottom. So we're going to require two common logs, so 2 logs. Let's do that in red. So we're going to have our 1/3, and then that's going to times all of it. And we're going to have a log and a log. And our first log is going to have that x plus y squared. Scoot that log over, give ourselves a little bit more room. And the bottom one is going to have a log of 10, or the second one's going to have a log of 10. We're going to close that. And again, because it was division, we are subtracting, right? We're subtracting. And we're a little out of room. Let's scoot this over and give ourselves a little bit more room. So what's going to happen next? Well, from here, we're going to see that we have another exponent right here that's got to move to the front of its piece. So we're still going to have that 1/3 and that bracket, and now that 2 can move to the front, and we'll have log of x plus y then we have our minus sign, and then we have our log of our 10, and we close our bracket. And then remember, we're trying to simplify this, right? So we have it expanded, but we need to finish simplifying it. Now the log base 10 of 10 is a 1. So this turns into a 1. So we can then rewrite this as 1/3 times 2 times the log of x plus y minus 1. Then from here, all we need to do is distribute that 1/3. So our 1/3 is going to distribute to this term and to this term. So as we distribute it to this first term, we're really distributing it to the 2 that's there. So this is going to turn into a 2/3 times the log of x plus y minus, and again, I'm taking that 1/3 and I'm multiplying it to that 1, which is going to give me a 1/3. And now I've written this in simplified expanded form.